What if I told you that beneath your feet, miles deep, there are massive, fiery hearts beating? These are Earth's magma chambers, the hidden engines that drive volcanoes and shape continents. Join us as we plunge into these incredible underground worlds to uncover their explosive secrets beyond the dramatic eruptions that capture our attention. Beneath the serene landscapes and bustling cities lies a dynamic, superheated realm. This is not an empty void, but a vast, interconnected network of molten rock, Earth's magma chambers. These subterranean furnaces are the planet's fiery veins, constantly at work, fueling our world's inner workings and shaping its very surface. They are the unseen forces, the silent architects, tirelessly sculpting our landscapes from the inside out. To truly understand our dynamic planet, we must venture into these hidden depths where unimaginable pressures and temperatures conspire to create the raw geological power that defines our home. This journey will take us far beyond the familiar, into a world rarely seen but constantly in motion, a world that holds the keys to understanding both the destructive power and the life-giving essence of our Earth. Beneath the surface, magma. Chamber Anatomido truly appreciate the power of these hidden hearts. We must first demystify what a magma chamber actually is. Forget the cartoonish image of a giant, empty cavern filled with bubbling lava. The reality is far more complex and fascinating. A magma chamber is not a hollow space, but rather a vast, complex reservoir of partially molten rock, often described as a mush, a mixture of liquid magma and solid crystals suspended within it. This mushy consistency is crucial as it allows for the dynamic processes of crystallization and differentiation that shape the magma's composition. Within these subterranean furnaces, incredible pressures and temperatures converge. The deeper you go, the hotter and more pressurized the environment becomes. Temperatures can range from 700 degrees Celsius to over 1,300 degrees Celsius, depending on the magma's composition. The immense pressure from the overlying rock prevents the magma from simply erupting, containing it within these deep reservoirs. It's a delicate balance where the buoyant force of the less dense magma pushes upwards against the confining pressure of the surrounding crust. Magma chambers come in a surprising array of shapes and sizes, defying any single description. Some are relatively small, localized pockets, perhaps only a few kilometers across, feeding individual volcanoes. Others are colossal, continental-scale reservoirs, like the one beneath Yellowstone, often referred to as supervolcano magma chambers. These can extend for tens of kilometers and hold enough molten rock to reshape entire continents. Their shapes can be irregular, like sprawling networks of interconnected sills and dikes, or more defined, like dome-shaped or tabular bodies. Scientists use seismic waves, much like medical imaging uses X-rays, to see into these hidden depths and map their intricate geometries, revealing a world far more intricate than once imagined. Magma's dynamic dance, shaping our world far from being static pools. Magma chambers are active, ever-changing systems, constantly engaged in a dynamic dance that profoundly shapes our world. The movement of magma within these chambers and its interaction with the surrounding crust is a primary driver of some of Earth's most dramatic geological phenomena. This subterranean ballet directly influences plate tectonics, the grand, slow-motion collision and separation of Earth's massive lithospheric plates at divergent plate boundaries. Where plates pull apart, magma rises from the mantle to fill the void, creating new oceanic crust. This continuous upwelling of magma from chambers beneath mid-ocean ridges is the engine of seafloor spreading, a fundamental process that has shaped our planet's oceans and continents over billions of years. Conversely, at convergent plate boundaries, where one plate dives beneath another in a process called subduction, the descending plate melts, generating new magma that ascends to form volcanic arcs. The magma chambers beneath these arcs are the crucibles where new continental crust is forged, a slow but relentless process of planetary growth. Beyond the grand scale of plate tectonics, magma movement within these chambers connects directly to more immediate and observable phenomena. The shifting and pressurization of magma can induce seismic activity, leading to earthquakes. While earthquakes don't occur within the liquid magma itself, the stresses exerted on the surrounding brittle rock can cause it to fracture, releasing energy in the form of seismic waves. These tremors can serve as vital clues for scientists, indicating changes in the magma chamber's state and potentially signaling an impending eruption. The heat from magma chambers also fuels hydrothermal systems, leading to the spectacular displays of geysers and hot springs. As groundwater seeps deep into the earth, it comes into contact with superheated rocks surrounding the magma chamber. This heated water, under immense pressure, then rises back to the surface, erupting as geysers or forming serene hot pools. These geothermal features are not just tourist attractions. They are direct windows into the energetic processes driven by the hidden magma below. Furthermore, the cooling and crystallization of magma within these chambers are responsible for the formation of many valuable mineral deposits. As magma cools, different minerals crystallize at various temperatures and pressures, often concentrating rare elements. This process, known as magmatic differentiation, can lead to the formation of rich ore bodies, including copper, gold, silver, and other precious metals, which are vital to human industry and technology. From the majestic peaks of mountain ranges, uplifted by the intrusion of magma, to the fertile soils enriched by volcanic ash, the unseen power of magma chambers profoundly influences the very landscapes we inhabit and the resources we depend upon. Living on a molten Earth risks and research. While the dynamic dance of magma chambers is essential for shaping our planet and providing valuable resources, living on a molten Earth also comes with inherent risks. The most immediate and dramatic concern is, of course, volcanic eruptions. When the pressure within a magma chamber exceeds the strength of the overlying rock, magma can force its way to the surface, leading to eruptions that can range from effusive lava flows to explosive, catastrophic events. These eruptions pose significant threats to human life, infrastructure, and the environment, releasing ash, gases, and pyroclastic flows that can devastate vast areas. Beyond direct eruptions, the ground above active magma chambers can deform, rising and falling as magma moves and pressure changes. This ground deformation can damage buildings and infrastructure, and in some cases lead to the formation of calderas, large, basin-shaped depressions formed when the roof of a magma chamber collapses after a major eruption. The potential for a supervolcano eruption, like the one associated with the Yellowstone caldera, represents a global-scale threat capable of altering climate patterns and causing widespread disruption. Given these risks, scientists are constantly striving to understand and monitor these inaccessible depths. The challenge lies in studying a system that is miles beneath our feet, hidden from direct observation. However, cutting-edge scientific methods and technologies are providing unprecedented insights. Seismic monitoring is a primary tool, as earthquakes and seismic waves generated by magma movement can be detected and analyzed to map the size, shape, and depth of magma chambers. By deploying networks of seismometers around volcanoes, scientists can track subtle changes in seismic activity, which often precede eruptions. Another crucial technology is satellite imaging, particularly techniques like INSAR interferometric synthetic aperture radar. INSAR uses radar signals from satellites to detect minute changes in ground elevation over large areas. This allows scientists to observe ground deformation, uplift, or subsidence caused by the inflation or deflation of magma chambers. GPS receivers also provide highly precise measurements of ground movement, complementing satellite data. These geodetic techniques offer a real-time picture of what's happening beneath the surface, helping to assess volcanic unrest. Furthermore, gas emissions from volcanoes are carefully monitored. Changes in the composition and volume of gases like sulfur dioxide and carbon dioxide can indicate fresh magma rising into a chamber or changes in its degassing processes. Thermal imaging, both from the ground and from satellites, can detect changes in surface temperature, which might signal increased heat flow from a shallow magma body. Current research is also delving into the petrology of erupted rocks, analyzing their mineral composition and textures to reconstruct the conditions within the magma chamber before an eruption. By combining data from these diverse methods, volcanologists are building increasingly sophisticated models of magma chamber behavior, improving their ability to forecast eruptions and mitigate risks, allowing us to live more safely on our dynamic, molten Earth. The unseen power, Earth's fiery future. As we delve deeper into the mysteries of Earth's hidden magma chambers, it becomes clear that their influence extends far beyond immediate volcanic threats or the formation of mineral wealth. These subterranean powerhouses are fundamental to the long-term geological evolution of our planet, constantly shaping its future landscapes. Over millions of years, the relentless processes driven by magma chambers contribute to the growth of continents, the opening and closing of ocean basins, and the ongoing cycle of mountain building and erosion. They are the deep-seated architects of Earth's grand geological tapestry, working on time scales that dwarf human existence. The very existence of life on Earth, as we know it, is intricately linked to these fiery processes. Volcanic activity, fueled by magma chambers, has played a crucial role in releasing gases from Earth's interior, contributing to the formation of our atmosphere and oceans. The fertile soils found in volcanic regions, enriched by mineral-rich ash, support diverse ecosystems and agricultural productivity. In a profound sense, these hidden hearts are not just engines of destruction, but also vital sources of renewal and creation, continuously recycling Earth's materials and fostering conditions conducive to life. Our relationship with these powerful natural forces is one of both awe and necessity. We are drawn to the dramatic spectacle of eruptions, yet we also depend on the resources they create and the dynamic processes they sustain. As humanity continues to expand and our technological capabilities grow, so too does our ability to understand and interact with these deep-seated geological systems. The ongoing research into magma chambers, utilizing ever more sophisticated tools and techniques, is not merely an academic pursuit. It is a critical endeavor for our collective future. By unraveling the complexities of magma chamber behavior, we can improve our ability to predict volcanic eruptions, mitigate their impacts, and harness geothermal energy more effectively. We can better understand the formation of valuable mineral deposits and manage these resources sustainably. Ultimately, by comprehending the unseen power that beats beneath our feet, we gain a deeper appreciation for the dynamic, living planet we inhabit. Earth's magma chambers, these hidden fiery hearts, will continue their ceaseless work, sculpting, creating, and defining our home for eons to come, a constant reminder of the raw, untamed geological power that truly defines our world.